guess I introduce myself. Yeah, because the next talk is actually mine, and I would like, yeah, there's Pablo. Do you want to make the introduction?
I'm here.
Yeah.
Next speaker, Ulrich Hoffmann with Docker Ford.
Exactly. So,
Come on.
yeah, let's see. I share my screen and we will see what it is. So the idea actually about that is I want to use and experiment with lots of different force systems. And so there is this web page, or let me first get this Zoom stuff here out of the way. There is there's Docker, which is actually the capability to run programs inside so-called containers, which are small, lightweight, well, you can call it virtual machines, execution environments where you can install all the dependencies of a program and the program itself. And when I learned about that, I thought, well, that's probably a good idea to make, yeah, to satisfy my desire to try out different force systems. And you describe how to actually go ahead and install a system on a plain Linux system. And then you can actually have it prepared so that it can run in the appropriate environment. And so I started doing this, and let me see, maybe we look at the portable force environment, how these things actually look like. PFE, let's click there. There's a repository called Docker Force under my account. And it collects many open source force systems so that you can make them run on your desktop within these containers. So what a Docker file looks like, it actually describes from a given base system, which in this case is Debian Buster, an older force system, the steps you need to do to install actually the appropriate program or force system in our case on that environment. So what you need to do is you start with Buster, you create some directories, then you do an apt-get update, you install software. PFE is written in C, so you need to have the C tool chain to actually do this, like automake and GCC and make and bzip2 to unzip the directory, and wget to actually get the appropriate distribution. And then what you need to do is to install this. You go ahead and fetch it from SourceForge in this case, and you extract it. And once you extract it, you cd into the directory, and you do some patches maybe to have less warnings, and then you do what you typically do on it with a Unix program: configure, make, install, and then I want to run the container. You have to execute /user bin pfe to actually do that. And let's see how this looks like if we go to pfe. Then we can say make. Yeah, just make, and this goes ahead. It takes Buster, it downloads the image, and then does the appropriate steps to install all the different things. And we keep this running because it takes a while, and we switch back to the force systems that we have here. So it's actually a nice collection of different systems like GeForce in different flavors. If you prefer to try out something with a 32-bit version with lib foreign function installed or without, this is also for developing on these systems. You go ahead and you see it's fairly old systems. Even the GeForce 64-bit version 0.6 is quite old, but there's also a GeForce Current that we will look like in a moment. And then K-Force is there, and Albert van der Horst systems. And well, maybe we come back to Matrix Stellaris, which actually is an ARM force system. So if you want to run it in a container, you have to supply an ARM emulator to do so. Yeah, and this is what it actually does. Then we have MinForce, we have PFE, MuForce, MyForce. So many force systems I just stumbled on. And also we have commercial systems that have eval versions. And for all of the open source systems, there is also another possibility to execute this actually, or several other capabilities, because the repository is in a way whenever something is modified in the appropriate directory. So here is the list of all the systems. If something is modified in these directories, an image like what we do in the terminal right now is automatically done within the GitHub cloud. And then the appropriate images of the containers are pushed to the repository. So you can go ahead also run here, go ahead and say, well, let's say we want to call, execute UEForce. Then UEForce is the system name that we want to use. And well, this is still running, but well, I just open another terminal and let's see how we do this. I can say UEForce. Run this in a terminal interactive mode, and after I've finished the system, please remove the container again. Yeah, this is the environment variables are not set. Docker machine environment. That sets some environment, and I have to eval that in my shell to actually set the environment variables. And once I did this, I can then run this command. And it says, well, on my laptop, the image is not available. So it just downloads the image of the prepared force system and combines it. It does so with some kind of download management and downloads several layers. And it takes sometimes, but it's much faster than building the image on your own. And so what you can do is once this is downloaded and the other things are extracting still, and then we will see. Actually, this download process is only done once because the images are cached on the local system. And I wiped them out just before the presentation to demonstrate this during this talk. So here we go. Actually, it's out there. And here we go. And we have a UEForce running here. And we can make some experiments with it, try it out. And UEForce is the PC version of ESP32 Force from Brett Nelson. Yeah, so that is what you can do right now. Let's see what's happening here. PFE is ready. So it did all these steps that I described earlier. And now what I can do is make run. I have a system on my own. And here we have PFE running with its setup. And I can see words. And okay, this is a primitive one. Whatever, lots of primitive things. I don't think that PFE has any high-level words that are not defined in the system kernel right now. And yeah, anyway, you can say make to create the image. You can say make run, also create the image locally. You can say make run to execute the force program, and you can make xlerp because there is a source directory, and within this source directory there is a file xlerp.fs, which is some simple test program that just says hello and then defines a loop and let it run. And that's interesting to see if you can and how you need to do what you need to do to actually make it run on a specific system. Yeah, so make xlab actually does this command line, and a PFE expects a file name on the command line, and that's the one that you would use. So you have connection to the local file system if you want to. You see, it's a little bit more complicated. You have this -v option to actually map the container directories or some of the container directories to local directories on your system. Right. So what we can do, and so now that is probably interesting. We go to GeForce current because, well, as you probably know, there's an ongoing GeForce development, but the archives that you find are more or less outdated, like we saw 0.6 something. And if you get installed GeForce on a modern Debian Linux system, you get an outdated version, but you want to have a new one. So I already did before a make to create the image. So it's very fast right now to have the image. And if I say make run now here, then it starts, and it's the version from 8th of February this year. With all the nice things, so you can see words and use the debugger, and you see the color and the status line. So if you put something on the stack, it will show up down there, and you can do the appropriate calculations and whatever, and use GeForce in this way. You can also say make xlab, of course, to use the xlab file. And you see it's GeForce is invoked in a different way. You provide a file name, and then you, with the -e option, you can add additional force words that get executed after that. So if you just want to run this file, you do it like this. Right. So this is if you want to use this on your local machine. You have to install Docker, of course, the runtime that allows you to execute these containers. But if you don't want to do that, there is another way that you can do. And if you go to the repository, let's see, how can we go to the repository to the top level? You see this green code. This is where you normally clone the repository. But it's for some time now, it has also this tab. It's the code spaces. Yeah, and this is a development environment that you can use that works in the browser. It actually hosted on the GitHub cloud, and so you can actually go there. And I already started a code space. And if not, then you just see a green button here and start a code space. You have to be logged in with your GitHub account. But if we go there, then what we get is hopefully not another one. Yeah, it works. You get a instance of Visual Studio Code that runs in the browser, and that gives you access to the repository and to appropriate the appropriate files. So here you see you get the README and the appropriate preview, and you can go ahead, and it gives you a journal. Just do what I did without installing anything. Yeah, you can just go here, and we can go and say, well, let's go to PFE and do a make. There's Docker installed in that development container. So you can just go ahead and do what I did just on my local system. You can also do in the cloud right from the repository, where you say, okay, open a code space. And then within that code space, you can try out all these different systems. One thing that the repository supplies is these prepared images that you can just run with a command line that I showed earlier. Yeah, like docker run -i -t, and then you say you prefix this with docker run docker force. then you don't need to build them inside this development environment. The exception is that the commercial systems, I don't provide any images for them because of legal reasons. I don't think the vendors are happy that I will provide images of their systems on a publicly available platform. So they want to have control about their evaluation versions or whatever. But what you can do inside this, well, maybe we just break it. We saw this earlier. We go to VFX, for example, VFX. And let's have a look at what the VFX description actually does. Here's the Docker file. Very similar. It starts with Buster. And it goes and fetches the VFX Force eval distribution from their website. And for the moment, it builds it so that you can run it here. So let's see how this works. And if I say make here, then it will go ahead, use Buster, do an appropriate update. Because the vendors provide their system in binary, there is no need to have a C toolchain or whatever installed. You just want to run the environment there. It downloads the eval version of VFX, it does it, and it creates the appropriate installation, does the installation step that you normally do when you read the README file and say, what do I need to do to install the system, which is essentially go to the VFX directory and invoke the install me lin32 shell script, which then does the magic and installs it in the system. But the system currently is the Docker container that we're creating. So once we did this, we can make run. And there we are. We have the quite up-to-date VFX system, right, downloaded from the eval website. I don't know why it's ended in 2020 with a copyright. Anyways, so we're just leveraging the available eval version. And the contribution of the Docker Force repository is actually that all the necessary steps to install this or this or this system has been captured in these Docker files. So you don't need to figure out or read documentation. You can just go ahead and do this. And maybe finally we go to Macrisp Stellaris and also have a look at that. What is the Docker file for Macrisp Stellaris? Very, very simple, as you can see. And why I discuss this, well, let's see, we make this image. Yeah, just make. What's going on? I don't know. Anyway, yeah, let's see what the makefile looks like. Aha, it has some debugging rules in it. So what we need to do is make image here, which normally is the first target. So let's have a look at the Docker file. It starts with Debian Buster. Well, all these Docker files have been prepared some time ago when Buster was actual. So today you want to use Bullseye probably, and maybe Bullseye Slim to not have all the non-needed packages installed. It installs QEMU and wget to get the binary of Macrisp, and then it goes to SourceForge, downloads it, and expands it. There's nothing to build, yeah, because Matthias Koch provides the binary of Macrisp as well. Otherwise, you have to assemble it. So yeah, and you see this is what happened, and now we can just make run. And tada, we get Macrisp Stellaris, which is an ARM4 system running in this container, and we can do words. Yeah, and we can figure out that if we want to do a variable, yeah, say variable x, well, this doesn't work because Matthias decided to have variable in a figforce style, where you have to supply an appropriate value, x, and then you can say x fetch dot Yeah, and 55 XStore X fetch dot and 7. What do we say? Minus 13 X plus store and then X fetch dot web dot. Wow, the answer is 42. Great. Yeah, so I think I would encourage you to have a look at this, give me feedback. If you have a force system that you want to see on the Docker Force webpage, being able to run. Docker actually typically supplies a Linux environment for running these programs. We could do some stunts with Wine that we install inside the Linux container and then try to execute Windows programs as well. But so if you want to see some force system in there that I didn't find yet, then just contact me. And if you find any issues, then yeah, also let me know. I would encourage everyone to play around with this and see if it works and give me some pointers to what any issues might be. So yeah, that's it. So you can use any of these force systems as a single click, more or less. Thank you very much for listening to my talk or my presentation.
Thank you, Ulrich. Very well.
Excellent. Excellent.